Thank you very much. Thank you for coming. I appreciate you attending my talk. I hope you're in the right room. So I'm Marty. I'm a software developer, have been for about 20 years. And these days, I'm fortunate enough to work on open source projects professionally as a gig. And so I get to work on a couple of projects. I work on a thing called Taxi, for which I am the language and project lead. And Taxi is a language for adding semantics to our APIs, and then using those semantics to automate integration. And then Orbital is a platform that we built around that, which gives you a nice runtime and developer tooling and kind of observability. They're all open source. They're up on GitHub. You should go and check them out and give us a star afterwards as a way of feeding us internet points. But kind of the idea behind these technologies, and I guess also the theme of my talk today, is around integration and kind of how we build integration and some of the challenges that we have with that, and kind of trying to explore an approach for integration that's kind of fundamentally different from the default way that we do it, which is kind of this, right? Where you have a source on one side and a sink on the other side, and you have some glue that stitches it together. And that's true kind of regardless of whether you're building microservices or event-based architectures. And it's true whether the glue is kind of coming out from code that you write or from some YAML mapping framework, or if you've got a budget and gone out and bought an enterprise integration tool, right? It's always the same kind of thing, right? Source on one side, sink on the other, and someone builds some glue to stitch them together. And so my talk kind of breaks down into like a 10-minute rant about this. And then I'm going to start like exploring some ideas that are different and kind of some of the principles behind Taxi, and we'll talk about how it works, and then we'll do some live coding and pray to the gods. So the whole kind of idea here is to explore the concept of integration, right? And integration starts when we have a producer on one side that has some data or some services or some capability, and on the other side we have a consumer. And the consumer wants the producer, and so they build some integration, right? And that's it. That's the entire talk in one slide, right? And we're going to talk about this almost exclusively. The problem is it's not quite this simple, right? In a lot of enterprise organizations, before you even start, the landscape looks a little bit more like this. So before the consumers can do any kind of coding, they have this journey of discovery that they have to go on to track down the data sources that they want to get their hands on, which leaves kind of consumers feeling a little bit like this, right? There is this process of who has the API that has the data, who has the currency converter API, which team has there's 7 currency converter APIs, well, we'll build an 8th, right? So there is a massive discovery problem, but we won't focus on that too much. Our consumer has found their producer, and they set about building some integration. And the producer has a REST API, and so the consumer's like, great, it's a REST API, I know what to do. And they get their OpenAPI spec. And that is, I'm glad that lands, because I'm of an age where this is kind of aging out now. Okay, and so the consumer gets given the OpenAPI spec, and they have a bunch of work that they have to do, right? This is where the work starts. And they have to get the API spec, and they have to plumb it into their framework of choice, their language of choice, and they have to generate a client, and they have to think about mapping like the field name coming from the producer into the consumer and map that together. And they have to think about failures and retries and what happens when things go wrong, and keeping it fast, so doing some caching. It's just like a bunch of work. But the consumer is finished, and they've built their integration. Of course, it's not quite this simple, because in actual fact, they need to connect to multiple producers, right? They need to pull data from multiple microservices, from multiple Kafka topics. And so we're back here. And so the consumers find themselves, again, kind of like, come on, man, we've been through this path. But our consumers find their producers, and they get given their API specs, and the work continues. And now there's more clients to generate, and more field mappings to produce, and more this thing is that thing. And now we have to think about, there's multiple services, so we need to think about orchestration and sequencing. We need to think about parallelism and concurrency. We need to think about cascading failures. When things go wrong, how do we stop the whole thing from blowing up? And so there is just like a lot of work that is going on in this. I feel like my mic keeps cutting out. Does it keep cutting out? No? Good. Okay, cool. So there's like a bunch of work that happens here. But our consumer is finished, and their job is done. Now, of course, it's not quite this simple because there's multiple consumers across the organization. So across the org, this journey is going on, and they are discovering their APIs, and they're discovering their Kafkas and their databases, and they're building their clients, and they're doing their mapping. And this work continues, right? The integration work carries on over and over and over across the organization. And kind of the point here is that when we are building integration in an organization, consumers do a lot of heavy lifting, a lot of work, which kind of sucks because there's a lot of them, right? We've got this journey of discovery going on over and over and over across the organization. And this integration work that we're doing, like it's not reusable, right? One team building an integration doesn't make another team's journey easier. Integration code is not it's not an artifact that we easily reshare. It's generally very project specific. Now you might look at this and you might think I'm kind of over-egging the situation, and I'm afraid to say it's actually worse than this. When we think about kind of building an integration, it kind of breaks down into three, well, we think of it in three distinct phases, right? There's the design and discovery, like going off and finding all the APIs. There's the build work, and then there's the run work. And last year, a survey came out where a company went and talked to 1,000 mid-market and above, so 50 million in recurring revenue and above organizations about how they build internal integrations. And this study found that the average time to build and ship an integration in an organization is 3 to 9 months. Like, that's insane. 3 to 9 months to build an integration. We've got machine-readable specs coming out all over the place, and it still takes us 3 to 9 months. And every time I see that stat, I'm like, that cannot be right. And then we start working with a new client, and like, it's not far off. One client that we work with, the very start of their integration journey, before they do anything, they send a BA off into the wild, and they send them off armed with like a pen and paper and Confluent, and they document all of the different APIs that they're going to need to talk to, and they find the teams, and they build the API mappings, and they allocate 3 months for that before an engineer starts writing any code, just to get kind of the data onto the ticket. 3 months in an organization for every integration. That's broken. So we're back here, right? We've got our producers and our consumers, and they're all kind of wired up and everybody's happy. Now, of course, it's not quite this simple, because the producers aren't static either. And so the producers, inevitably, they ship a change, right? And so now we have version 2 of a producer. And needless to say, it does not go well. And across the organization, just everything explodes. And this is how every integration is built today in the organization. And that's kind of why we thought we want to have a crack at fixing that. So let's talk about coupling, right? The reason these systems are blowing up is because they are tightly coupled. Now, the Wikipedia definition of coupling is where on one side you have change, on the other side it leads to kablowie. If that is true, two systems are tightly coupled, right? Where you introduce change, it breaks something, the systems are tightly coupled. And as architects, we have a bunch of kind of strategies that we like to employ to loosely couple our organization. And they have varying degrees of success. One is microservices. We go, great, we're gonna loosely couple our organization by using microservices, and we'll use OpenAPI specs and everything will be fine. But we've kind of just seen the result of that, right? You introduce change into one of your API specs and stuff blows up. So then we go, well, I didn't mean that. I meant smaller. Let's get rid of the servers entirely and we'll go serverless, right? We'll get rid of the servers. That was the problem. And that doesn't really solve the issue. It just adds more things that we need to connect together. And if you change any of those, the consumers blow up. So we go, okay, well, I didn't mean that. Let's decouple them entirely. Let's not have them talk to each other at all. We'll put a queue in the middle, right? And so with a queue, we have a producer that drops a message onto a broker. And now the consumer and the producer don't know about each other at all. There's no communication between them. Now, of course, if you change that message, then the consumers explode. So then we go, okay, I'm going to use a gateway. I'll use something like GraphQL, okay? And this isn't a bad strategy. This one's actually quite nice, right? Because in this model, we have a thing that sits in the middle that is both a producer and a consumer. And it doesn't prevent change, but it does like kind of encapsulate the blast radius. So when something changes, yeah, the gateway blows up and we have to deploy someone to go and fix that. But the consumers are protected. Unless you change the gateway, in which case everything explodes. And this is problematic because like we want to change these things. We don't want to build architectures that prevent change. We want to enable change, right? So the problem is that when we build glue code, it tightly couples producers and consumers. The way that we are building architectures and the way that we are building integration tightly couples producers and consumers. So that's the rant. Let's talk about something different. Let's have a different crack at this. So the idea that kind of sits behind this space is we have our producers and we have our consumers, and we want to decouple them. So the idea is let's get our producers and get them to publish their API contracts, right? They're a good thing. And get our consumers, instead of getting them talking directly to our producers, get them to publish their requirements. And so we take this publication on both sides and we push it up to a thing, right? And the job of that thing is to handle the integration, right? It needs to, that becomes its job. But for this thing to be any different from all the other things that I've just shown you, it needs to adhere to two rules. The first is it has to be able to connect stuff on demand, which means when a project comes along, right, a brand new integration requirement, the thing has to be able to work out how do I orchestrate the different systems that I know about and the different queues, and how do I orchestrate that together to solve a problem, right? If it cannot be solved by deploying an engineer to go and build some stuff to solve the integration, it has to be able to work out how to do that on its own. And secondly, it has to be able to adapt to change. So inevitably, when we say you can't talk directly to my database anymore, you have to go through an API, or when like the Snowflake salesman comes a-calling and you go, you can't go to my API anymore, you need to go to my database, right? As we refactor our organization, as we change field names, as we do transformations, we have to be able to adapt to change. If when things change, we have to deploy an engineer to fix it, it's no better than what we just had. So the fundamental principle here is there must be no glue code. This cannot be a place that we go and write code. So that's kind of the idea here. We want a thing that doesn't use glue code. And it's all kind of powered, the whole thing starts with API specs. So let's talk about API specs. And there is this kind of underpinning question that I alluded to a bit earlier, right? Which is, if we have these machine-readable API specs, we've got these language agnostic, framework agnostic, everything agnostic kind of API specs that machines can read and they can understand how to integrate. Why is it the very first thing that we do with those machine-readable API specs is we give them to a human in our team to start doing some work with? Like that feels broken. So if we're building these machine-readable API specs, why aren't the machines building the glue, right? Why is it that we're still writing the glue code manually? And the answer is because our APIs aren't rich enough, right? Our APIs today talk about the address of a service, where I can find it, what's its IP address, what's its DNS entry, right? They talk about the protocol. Is it HTTP? Is it TCP? Is it HTTPS? What verbs can I call? Get, put, post. How do I send something across the wire? Do I zip it? Is it protobuf? Is it JSON? And when I deserialize it, what field names can I expect? And that's it. That's all they tell us, right? That is transport and structure. Where are you? How do I talk to you? That's all they tell us, right? They don't tell us what any of that stuff means, right? APIs do not talk about meaning. They talk about transport and structure. And they don't tell us how any of that stuff relates to other stuff. And like, I get it, right? Like if I'm writing an API, I don't really want to be documenting how my API relates to the rest of the world. That's bad encapsulation, that's a bad thing, and that's not what I'm advocating. But these are the semantics. What we're missing is the semantics. APIs lack semantics. And semantics are the terms that we use to talk and think about data, right? It's the what the data means versus where to find it in a map. So semantic, the meaning of the data, first name, last name. Structural, what field name do I look this up in a map? So we think and we talk about code in terms of semantics, right? Given this customer's email address, what's their account balance? When we talk about requirements, when we write up JIRA tickets, when we talk about story points, when we do the whole dance, it's always semantic, right? We talk about it in the language of our business. But we code against structure, right? Given this JSON path, what's the value at that JSON path? So we talk and think in terms of semantics, but we code against structure. And that's a good thing, because semantics of our business change very rarely. It's uncommon for a new term to enter the vernacular of your business, right? And it's uncommon that a business can't find agreement around a term if that term is small enough. So I'm not talking about a big complex concept like customer. I'm talking about a nice scalar concept like first name, last name, date of birth, right? So the semantics of our business don't change very much. But the structure changes all the time. Everybody in this room is in the business of shipping change to the systems that model those semantics, right? Refactoring services and shipping new cloud things. And like we are just constantly changing, continually integrating, deploying, testing, releasing to production 5,000 times a day. So we think in terms of semantics, but we code against structure. So I want to look at some kind of semantics and some structure. So I've got some data here, right? And at the top, I've got some API contracts, and at the bottom, I've got some blobs of data. Okay, three different domains: customer information, card data, and balances, and three different blobs of data. And if you squint a little bit and look at this, some relationships start to appear, right? So these two fields, different names, modeled by different teams, stored in different systems, but the same bit of information, right? The same thing. Customer has a field called ID, cards has a field called customer number, same thing. Likewise here, between cards and balance, right? Different field names, different systems, different protocols to talk to them, but the same bit of information, right? And so this is not a talk about field names. Teams should design field names. You should design your domain. You should own your domain. But what's missing here is a way of expressing, hey, this thing is the same as that thing, right? It's kind of this. We want a way of being able to say in our specs, this is a field name, which is how to look it up in a map, but this is what the data means. And it's modeled using our ubiquitous language, right? It's modeled using the language of our business, not a specific system concept. And that's what Taxi is. Taxi is a way of capturing semantics and sticking it in your API, a way of saying, this isn't just any old integer, but it is a customer ID. This isn't any old string, it's a card number. So that's Taxi. It's a language for APIs, data, and kind of how it all hangs together. It's up on GitHub. You should go and check it out. So it's semantic metadata. Taxi is semantic metadata. It's a way of saying this thing is the same as that thing. That's all it is. So where API specs talk about transport and structure, the where and the how, Taxi talks about semantics, the what. And the idea is to bring these two things together. So you don't replace your API specs, you carry on using them. We don't care what your API specs are. You carry on using them as you were, but you add some additional metadata. So Taxi is designed to be embedded in API specs. You can chuck it in your protobuf, your OpenAPI, your SOAP, your JSON schema, whatever, right? It works alongside your existing API specs. But these aren't just random strings that we put in here. It's a full semantic type system, right? It's compiled, it has build tooling, it has linters, it has all the kind of stuff that you want to make sure that you don't accidentally make mistakes and that you're following good practice. And you can use Taxi for describing standalone objects, right? If you've got ad hoc CSV, you've got an ad hoc JSON that doesn't have a schema, you can use it. We use it as an OpenAPI alternative. You don't have to. We hate YAML. But you don't have to, and you probably won't, right? You carry on using OpenAPI, and you can embed it in there, but you can use Taxi as a standalone. So here's our example from before: 3 different systems, 3 different teams, right? And the first team are using OpenAPI specs, right? And so all they've done is added a little bit of metadata to it that talks about what this field means in the broader organization, okay? The next team are using protobuf. So again, they have added some metadata to their API. And the third team is not using a spec, they are code first. So they generate their specs from their code, go the other way around. And so likewise, they can include some metadata inside of this is Kotlin, but you can do it with most languages. So that's Taxi. This thing is the same as that thing. It's a way of capturing that information in a place that's machine readable, that's not a Confluent wiki page, and embed that data in your API specs. So if we look at that earlier example of given this email address, what's the customer's account balance, and we apply a little bit of Taxi magic, right? We've got 3 different systems. We've got a REST API, we've got a cards table, and we've got a SOAP API. 3 different systems, 3 different teams, 3 different field names, 3 different naming conventions. But this time we're going to add some semantics into our API spec. So the first one, the email field is not just any old string, it's an email address. These 2 fields, different systems, different naming conventions, they're not any old string, they are customer ID, and so on and so forth, right? And we take those schemas and we publish them to our thing. And now what we can do is we can build this massive big graph of all of the different data and data systems that exist across our organization. And because it's a graph, we can do all kinds of cool graphy things with it, like we can navigate it. So given this question of given an email address, what's the customer's account balance, Without any code, without any GraphQL resolvers, without any kind of mapping files that we have to maintain, we can work out that the first thing we have to do is a REST API call to go from an email address to a customer ID. And then do a database query to go from a customer ID to a card number, and then do a SOAP request to go from a card number to account balance to find out that Jimmy's got 29 quid in his account. We can do that without anyone writing any code, right? We can work that out on the fly. So that solves the first requirement of can connect on demand. And again, all the stuff that we didn't have to do here, we didn't have to track down which systems own that data. We didn't have to track down their API specs. We didn't have to talk to the teams, right? We can work out and connect the stuff on demand. And so then inevitably when change happens and we come along and we say you can't talk directly to my database anymore, and we introduce version 2. And so we replace it with a gRPC API. And we follow some .NET conventions, so everything gets an uppercase letter. This breaks the integration, right? Where we had a database before, we don't anymore, but we have an API spec that has semantics. And so we can take that and we can publish it and we can work out how data relates across the graph. And so we can replace our database call with a gRPC call and it automatically adapts. Adapt to change. So those are 2 requirements, right? Don't write any code, and when stuff changes, automatically self-repair. So the only thing that's left then is to be able to ask this question. Given this email address, what's the customer's account balance? And that's what TaxiQL is. It's a query language for using semantics to ask for data, right? Given this email address, find the customer's account balance. So ask for data and generate the glue. So here's the example. It's declarative, right? It doesn't talk about systems. It doesn't talk about which database to connect to. It doesn't talk about field names. It talks about semantics, which means that as the implementation changes, we can rebuild the glue on the fly. And it's semantic. We're not talking about field names. We are talking about data by its meaning, which means we are decoupled from the producer systems. We're using the language of the business, the ubiquitous language. Here's a slightly gnarlier example. So given an email address of jimmy@foo.com, find the customer. That's the same thing. But this is where it starts to get interesting. The consumer, the consumer who's written this query is publishing their data contract. So if you compare this with kind of a GraphQL type approach where you have a single schema that consumers cherry pick from, right? With Taxi, consumers are publishing their data contracts. They're saying, this is the data that I want. These are the field names, this is the structure, which means there isn't a single thing that you need to change. We're removing that point of coupling. There's nothing here that talks about which systems to go and talk to. This is very declarative, right? Go and get me these fields. Taxi has a really nice expression language where you can embed kind of compute in your query layer. So we're going to uppercase the name and concatenate them together, right? Taxi has a standard library for doing all this stuff, but if you want your own functions, you can write them yourself. And these functions run on the query layer, so they benefit from caching and horizontal scalability and all the kind of stuff that you want by offloading your compute. And finally, we can use constraints on our data to say, hey, I want a collection of transactions, but I don't just want any transactions. Give me the last 10 and order it by transaction date descending. And by consumers adding constraints on their data, this is the type of data that I want, the query layer can inform the choices that the query layer makes around, well, which systems can I talk to that can satisfy those constraints? Which takes us on to query execution, and that's where Orbital comes in. It's a query execution engine. Again, it's open source. It's up on GitHub. Go and grab it, check out the code. So if we take a look at kind of what that example looks like with a query layer in the middle, it starts with our collection of taxi terms that we chuck into a Git repository, right? First name, last name, date of birth, right? Scalar terms that we commit to a Git repository, and we point it at Orbital. So it reads those. And then our producers, when they're building their API specs, they add that metadata into their API specs. The consumer of data uses those same terms to ask for data. So they write a TaxiQL query and they push it up. It feels a lot like GraphQL, right? They're sending a request for data, but they're defining their own schema contracts and there's no resolvers that we need to build in the middle. And now Orbital has enough information, right? It knows where these systems are, it knows how to talk to them, it knows how they can connect, so it can build the integration on the fly. We get the data, we return the results, we capture tracing and lineage and performance data and all the kind of stuff that you need when you want to debug what's kind of going on at runtime. And there's no glue code, which is kind of the big upside. Then inevitably, someone introduces some change. The reviews team release the next version of their API. Not a problem. They publish their API spec up to Orbital, right? They publish the change, the query adapts, we call the new API, and the client remains unaffected. No glue code. So that's it. Those are our kind of 3 parts. Taxi is semantic data for APIs. This thing is the same as that thing. TaxiQL is a query language to let you ask for data, and we generate the glue. And Orbital is an observability platform that we build around that. Demo time. Right. Hope everyone's feeling forgiving. Okay, so I'm going to run through a demo that takes place in the world of films. So we are a film production company. Congratulations. We have a database of films, and we have a bunch of microservices that have data that we can find out about our films, right? Where I can watch it, which streaming services have it, what kind of reviews are people saying about it. So we have this kind of estate of data. And we are built on Spring Boot. So Orbital and Taxi are framework agnostic, language agnostic, everything agnostic. This specific demo happens to be built in Spring Boot. So I have here a Spring Boot microservice that is returning review data, right? So you send it a film ID, and it will give you back a film review. Okay, it's a very plain vanilla Spring Boot microservice. There's nothing fancy about it. And what we want to do is add some semantics to this. So I'm going to jump into VS Code into my Taxi project. And this is what Taxi looks like in the wild, right? It's a collection of types that have semantic meaning. Film ID, title. There's no structure here. This doesn't talk about systems. This just talks about semantics. And I have, inside my project, I have a Kotlin generator wired up. Again, because this demo happens to be in Kotlin, we're going to generate some Kotlin code. And so all I do is I run the build. Okay, and what gets produced is a Kotlin project that kind of spits out there. If we take a look at what's created, there's nothing particularly fancy here. And because this is Kotlin, these are a bunch of type aliases, right? They're just type aliases that are adding semantics to our things. This is a big decimal. We're adding some semantic data to it. So I have now a library of semantic types that are built into Kotlin, so I can jump back into my Spring Boot project. And I can add some semantics into my API. So I can say, hey, this doesn't just take any old integer, it takes a film ID, right? And thanks to the power of demos, here is my response that I have prepared earlier, so you don't have to watch me type it out. But we have a film review that has 3 fields on it, a film ID, a film review score, and review text, okay? And that's it. This demo is configured to publish its schema to Orbital on startup, so we're just going to bounce it, and we'll jump over into the code. So this is kind of this is a view of Orbital's world. So we have a database that has a films table. That film has a bunch of fields, right? They've got some semantics in there. One of them is a film ID, which we can plumb into these microservices to find out reviews, and we can find out where I can watch it. Is it on Netflix? Is it on Hulu? Like, which streaming service has it? And so now that Orbital understands this, I can start asking some questions. So I can write a TaxiQL query. So I can say, hey, find me some film data. Can you guys see that up the back? Yeah? Okay, cool. So I could say, find me some film data, and we can run that. And sure enough, we get some data back. Not particularly exciting. This is a database query, right? We have made a very complex way of running a database query at this point. But I'm going to define the consumer contract of stuff that I care about. So give me ID field, which is film ID. Give me the title, and give me the year it was released. Okay, and we run that. And again, all I'm doing at this stage is defining a consumer contract. This is the structure and naming conventions that I want in my data. I don't care where it's coming from. This is the data I want. I can tell you it's all coming from a database query. We can, in fact, look and see there is a database query that is running here to get these fields back. Now I'm going to ask for a little bit more information. Give me the review score, and give me the price. There we go. And if we run this, there we go. And so we're getting back now a list of films with some reviews and some prices. Now this one's a little bit more interesting because that data is not coming from my database. right? If we take a look at the integration that's kind of run here, everything starts with a database query, and then we're taking those film IDs and we're plumbing them into different systems, right? A different system to go and get the film reviews and another system to go and get where I can watch it and its price. Now again, for me as a consumer, I didn't have to work that out. I don't have to know which team has the system that has pricing data, right? I don't have to know and do any of the discovery. I don't have to get their API spec. I don't have to generate a client. I don't have to think about any of that stuff. The client has been created for me. So I'm happy with that. I like that. I'm going to quickly save that. And we'll call it, we'll call it Brisbane. And I'm going to publish that as an HTTP endpoint. Okay, and that's it, right? So I'm going to quickly copy that as a curl so you can see it's a real thing. We'll jump over here. I'll curl it. Okay, and so there's our data that's kind of popped out. So we've built an integration that stitches a database and a couple of microservices together, turned it into a REST API, and we've curled it. So I'm happy with that. I am going to break it now. So it has come to pass in our film studio that we've been writing our own reviews, and word has gotten out, and the industry has suggested that that is a bad move. So we now need to pull in reviews from an external service. And so the API is kind of the same. They have an API that takes a film ID and gives back film reviews. But we're buying them from an external company. So we're buying them from a company called Squash Tomatoes. And they don't take the IDs that live in our film database. They have a different ID scheme. So they have Squash Tomatoes film ID, right? So we've generated semantics. The key point here is that even though they're both integers, even though they're both film IDs, semantically, they're different, right? They're not the same thing. This thing is not the same as that thing. And so on my response object, our field name is called film ID because whether or not it is a film or movie is hotly contested amongst our industry, as everyone in this room knows. But they've called it film ID, so the field name is different, and it returns a Squash Tomatoes film ID. So I'm going to bounce my service, and again, in doing so, it will generate an updated schema, publish that up to Orbital, and we'll jump over into Orbital, and you see the schema's been updated. So I'll rerun the query, and we still get our data out, right? So we're still getting our reviews, everybody's happy, the consumers haven't changed. But if we jump into our profiler, we can see now the integration is different, right? So where previously we were taking the ID out of our database and feeding it over to our films review service, we can't do that anymore because the films reviews don't speak our IDs. So we've had to do this additional hop, right? And most of us have done these kind of services where you have to do entity resolution along the way, right? So we have done this additional hop to go from our film IDs to the Squash Tomatoes film IDs to then call the Squash Tomatoes film service to get the film reviews back. And if I jump back over in here and recurl my statement, for me as a consumer, I don't know about any of those changes, right? The producer changed, the graph changed, but there were no GraphQL resolvers for me to go and repair. There was no YAML mapping file that I had to go and update. There was no drag and drop canvas that I needed to go and fix this up on, right? The producers who describe their data changed, and so the integration adapted. Okay, time for one more, because I've spoken very fast. Okay, this has all been kind of request-response kind of data. So we also have this Kafka topic that publishes protobuf messages. And every time Netflix announces a new film that they're adding to their catalog, they put a message onto this Kafka topic, right? And it's got a film ID and an announcement that comes along with it. So I want to stream this data, but again, I want to stream it on my terms. So I'm going to use exactly the same data contract before, so you don't have to watch me type it out. So I want to stream this data, but I want to stream it as this kind of this consumer contract. This is the shape of data that I want to consume. And so I run that query, and here we have now a stream of data that's coming out. Okay, and I can curl that as well. Hopefully. There we go. So we've got the stream of data that's coming out. But if we look at the integration that has run there, it looks very different. So it all kind of starts with this Kafka connection that we're connecting to, right? And now we have 3 sets of IDs. We've got Netflix film IDs, we've got Squash Tomatoes film IDs, and we've got our film IDs. So there's a lot more entity resolution that has to go on. And so it's a very different integration graph. Not that I know about that, not that I care about that. All I did was specify the data that I wanted and left it to the machines to work it out. So there you go, that's it. That's demos. So, summary, glue code sucks, right? Let's not waste our time building it, right? It's time consuming, it has very low reuse, and it breaks. Yeah? Make the machines write it. API specs are all about transport and structure, the where and the how. Taxi is all about semantics, the what's. Stick them together, we're gonna have a good time. Taxi is simply semantic metadata. This thing is the same as that thing, that's all it is. TaxiQL is a semantic query language, right? Ask for data, generate the glue. And Orbital is a platform for automating the glue. It's a runtime. That's it. I'm sorry, I've clearly pushed through that at a rapid pace, but we've got time for questions.
Thank you very much, Marty.